Take it away, Andrew.
All right, so I will. The slides up and running. So today is class number 4 of what has turned into a 4-part series on Intro to R for folks at Center for Healthy Minds. All of the classes and their recordings and all of the materials are on OSF, and they'll be kept there in perpetuity, hopefully. So people can go back and use this in the future. Today we're going to talk about visualization of data with ggplot, which is one of my favorite parts of the data processing and analysis pipelines. And so we're going to be looking at ggplot2, which is the main package for plotting data in the tidyverse. And so it comes as one of the standard packages. And if you just load the tidyverse library, you'll be loading ggplot also. The origin of ggplot came with the Grammar of Graphics, which is a book by Leland Wilkinson, which kind of presents a theory for how you should graph data and tries to kind of steer away from thinking of different graphs as these unique individual things like a box plot or a bar graph or a scatter plot, and tries to come up with a familiar grammar for talking about what is most similar between all the different types of graphs and break them down into components that can really be incorporated into code easily. And so Hadley Wickham, who we know and love, took that theory and implemented it into the ggplot2 package and wrote a great little paper called The Layered Grammar of Graphics, which I've avoided for a long time, but was looking at yesterday, and is actually very readable. So if you're a visualization nerd like me, you might get a kick out of it. The idea with ggplot is that there's really only 3 components to a graph. And so you have your data, and so that's the information being conveyed. And we've been working with a lot of data with this course. It's just, in this case, tabular data. And then you have geoms or geometries, basically how the data is visually represented on the graph. So if you just have data but no geoms, then you don't have a graph. And so with a scatter plot, the geoms that you're using are dots. And so that's represented here with turning the columns of data into a shape that can be seen. And then if you just have those 2, then you're not going to be able to know much or learn much from your data, because you don't have a system for relating it to one another. So the coordinate system is what the geoms are layered on top of, and the coordinate system is in most cases going to be an XY table that relates 2 scales to one another, but there are some other options that you can use in ggplot, and that gives you a plot. And so you might be asking, how do I do that in code? Well, ggplot is a pretty slick function inside of ggplot2, which allows you to make graphs. So you have your function, just ggplot, and then you give it the data. So that's the data component. You tell it where to look. And then you have a geom function. So there's a bunch of different functions that correspond to all the important different geoms. And then you give the geom function a mapping, which is what gives you the coordinate system. And a sort of strange thing is that for the mapping, you have to put the mappings inside of this aesthetics function. But I don't exactly know why. I think we talked about it a little bit before, but it's just a weird thing about ggplot. And so we can look at RStudio in order to get a better sense of some of this. And so this file is available on the OSF page under the class 4 section. And so if you want to follow along, you can download and find it. And the first section here is just all of the stuff that we've already done to clean up the data set that we've been working with. So I'm going to run that. And this is the same data set that we've been doing. And it's a data set from a meta-analysis that I did with Simon and Sinyu. And it was looking at attrition, so how likely people are to drop out from mindfulness-based mental health intervention studies. And since we don't actually care for this course or lesson about the cleaning code, I want to use a cool little trick of RStudio, which is that you can hide sections of your code so that you only are looking at something that you care about. And you get that option by adding these 4 pound signs at the end of a comment. So if I take away one of them, you lose the arrow and it's no longer a heading. But if I put it back, you get the arrow again. And another handy thing is that on the top right here, there's this button, which you can also get with the shortcut Command-Shift-O. And that shows you the outline of your headings. And so if you want to just hop to the data section that I made, then you can do that. And so it might not seem like it matters that much when it's a 40-line script, but when it's a 400 or 4,000 line script, that can really go a long ways to keep you oriented to where you're at. So I'm going to hide that, just use our plot the data section. So we've already run clean the data. And I just wanted to run this ggplot, which is we've actually seen each time in our lessons. It is what it has been at the end of the scripts to plot the data. And so if I run it, ggplot has a lot of default things that it will do in order to help you out. And it usually will tell you when it's made a decision for you. So here it is this layer is using this particular formula, which is good to know. It also gives you some warnings that there are some missing values, but we expected those, so that's all good. And so you can see we get a great little graph here, which shows the log of the mindfulness-based intervention attrition. So how many people drop out of the study. And then it is being compared with age on the y-axis to give us a coordinate system that allows us to relate the two. So we got a scatter plot here with a regression line running through the middle of it. And that is a pretty simple graph with not very much code here. I wanted to break it down just so you can really nail home how all this is working. So if you run plot2, where it's just the ggplot function with the data argument telling you to use the df variable, which is over here. It's the one that has all of our columns of data in it. When you just run that, you're just giving it data. So it is just going to create this blank space, which you can then plot things on. And so it's not useful really for anything, but it's good to know that this is how ggplot thinks of itself and how it was designed to follow the theory of layering. And so if you then supply the mapping argument with an X and a Y, it will give you the coordinate system, but you haven't told it what data, or you haven't told it what geoms to use to represent the data. So even though it knows that you want to use the age and the log MBI attrition data, it doesn't know how to represent them. So it just gives you the coordinate system. And so I also wanted to point out that you don't have to explicitly list the data and the mapping arguments. Most people don't. They just use the first position for the data and the second position for the mapping. And that works just the same as the one above it. And so here, we'll add a layer. And the yeah, Nate. So Nate asked, so you could pipe into a ggplot, and yes, you could. And that was what I think we were talking about that last time, where we're pretty sure, but don't quote us on this internet, that if it has data as the data frame as the first argument, then a pipe should work. So yeah, you could like just pipe it all the way from the read Excel into the ggplot, and it would produce the plot. ggplot, it has another weird aspect to it, which is that you add layers with a plus sign here. And so for me, learning it initially, it was a little confusing because it, in my mind, was kind of similar to a pipe. But in this case, it's not that you're pushing data from one function to the next. It's that you're adding a layer on top of the ggplot, if that helps you conceptually. So here we're adding a layer of geoms. So we got geom point. So run plot 5, and we just get all of our dots. And so those are the representations of our data. And then we can add another layer. And so you can think of it as, we're building up on top of one another. And so for this, it's a geom smooth. And so that is a stat layer, which adds a trend line to the data. You can see that I chose the method LM, so linear model, to do a regression line, because the default is to do a lowest line, which I feel like we don't really use as much in psychology. And a lowest line fits the data more exactly than the straight line of the regression. And doing this actually helped me to see that we have a bit of a slope. Well, we had a bit of a slope. Can I do that here? Nice. If you go back, you can get to your past ones. We have a slope here, so I don't know if it's significant, but it looks like there's some sort of relationship. When you look at the lowest line, you can see that actually it's pretty much flat all the way until here, when you have a couple of outliers really pulling it down. There's a big standard error. That's what the gray shadowing represents here. So that pointed out to me that actually the trend that we're seeing in the regression line before probably isn't much to follow up on, because it's really, I bet if you took out these 3 outliers, it would look almost flat. The ones all the way on the left of the lowest line, I'm not totally sure on this one. I think so. The log, I didn't do it very well. So because there are a lot of studies that nobody dropped out of, there's logs that are less than 0, and I'm not sure why that would make the lowest line do that, Nate, but it does something with the logs. So you can tweak the aesthetics, so the AES mapping, in order to add other aspects to the plot. So you can add color, which allows you to have a third dimension in your graph. And so you can represent three variables on the same graph. Here we're adding MBI adapted as the color. So MBI adapted is a variable for whether or not the intervention was intentionally adapted for the population. So if the study was only studying people who have a drug addiction, was the intervention actually adapted to treat a drug addiction? And this is not a very pretty graph because, at least for me, the standard error is kind of making it too crowded. So I'm going to look up by going to help. Yeah, I already did it. So if you search for geom smooth, there's a SE standard error parameter. So if you get rid of those standard errors, you can tweak it to false because it defaults to true. And so we can get rid of those. You can see that there is a little bit of a difference in the trends between the MBI adapted for yes or no. You can see that if it was not adapted, then younger people tended to drop out at a higher rate. And well, in this case, it's the average age. So if the age was younger overall for the population, they tended to drop out more. Again, probably not significant, but a nice little trend to look at. And it will default to picking colors and a lot of other aspects that you can also tweak. What do I want to say? Oh yeah, the tips. I think in that Tufts book that I was pulling out earlier, the recommendation that I usually hear is to try and not plot more than three variables on one graph, because oftentimes when you go try to get more on there, it just gets more and more confusing, and it's harder to actually pick out anything useful from the graph. So you can already see, like, if these lines weren't here, like, you can't even really tell if the red or the blue dots have any difference between them. And if I added another thing like shapes for, you can also tweak the shapes. So if I tweaked shape, I could maybe add gender as color and MBI adapted as shape, but it's going to be not useful for your audience. So just as a tip for that, there is a lot that you can tweak with ggplot, and we're just really scratching the surface here. But I just wanted to point out, to nail down the geom note idea, that these are a bunch of different ways to plot the same data. So here we're just looking at a histogram of the age variable, and with age on the x-axis and then the count on the y-axis. And so here the data is being represented by bars with the histogram geom. You can change the geom. So here we change it to area, and it's representing the exact same data, but it's with a different shape. And so all that takes is just changing which geom function you're using. And you can do that for this data with a couple different things. So you could also use this frequency poly, which is just the outline, or you could use a dot plot, a density plot, which is giving you a different y-axis, but it's representing the same data more or less. Or you can do a dot plot. where the dots, I think, correspond to some aspect of a percentage, but I'm not totally sure. You can see that it's got 1 through 0 to 1 on the y-axis. So like I said, this is really just scratching the surface of all of the potential here. And you're probably at this point wondering, that's great, but how do I know what all of the different geoms are? How do I know which one I should use when I'm making a plot? And so I'll point you back to the cheat sheets that I put on OSF a couple weeks ago. I put them in the materials for this week also. And so this cheat sheet is a huge lifesaver. It has just some theoretical stuff, basics of how ggplot is set up here, but then it breaks down all of the geoms into the way that they would normally be used. So these are just the primitive shapes. You can do a line segment, but this is where it really gets helpful. So it breaks it down by the data. So if you have one variable and it's continuous, these are the geoms that you can use to represent that data. And you'll recognize those are the ones that I just showed you for all the different ways to represent the age distribution. And then but it has a lot of different options. So if you have two variables and they're both continuous, then you have all of these options, how to represent it. If one's continuous, one's discrete, you have these options. And there's a lot of options. The next page gives you a lot of different ways that you can tweak your geoms and ggplots. And so you could teach a whole semester on just how to do good visualizations with ggplot. And I don't want people to feel like they're going away without resources. And so just to highlight how great it can be, you can learn a lot from a basic graph. This is from the R for Data Science textbook, showing that as the, I don't actually know what that's showing, but you can learn a lot from a simple graph, and you can make simple graphs really easily with ggplot. And if you want to see the code for making these, you can look in chapter 3 and chapter 28. And then you can see that you can also just make a really beautiful, really useful graph with ggplot. And in this case, it's representing the same data, just in this case, adding some extra dimension to the data with the different classes of cars being on different colors and then having a trend line. The resources I wanted to leave everybody with. Thanks, Nate. So this is my nice. So it's miles per gallon compared to engine displacement. So the higher miles per gallon, the lower your higher miles per gallon, the lower your engine displacement. And that's the beauty of graphics. If I just looked at a data set with that data, I wouldn't have been able to figure that out. So the resources, chapter 3 and chapter 28 are both on visualization in the R for Data Science textbook. It's got 2 chapters. I think it's the only topic that has 2 chapters, so it's important. This R graphics cookbook is an awesome book where Winston Chang goes through a lot of different situations that you might have for plotting data and gives you a solution with ggplot. If you want a more thorough course, there's data visualization course here that is recommended by the ggplot package makers. And then there's also this cool website which has a whole bunch of extension packages that people have written for ggplot. And it allows you to do all sorts of crazy graphs. Like here, your plots bubbles can move around. and just a lot of different really cool options for making graphs. So I, as always, am available to CHM folks if you want to talk more about any of the stuff that I've covered in these 4 classes. There's the OSF page, which I'll drop the link in the chat for. And while this is the last planned one, if there are ever any, we take requests. So if somebody wants a topic, you can always request it. And I'm sure Dan, Nate, or I would be happy to cover it. And as always, we love data. And so to the people here, if you want to leave me some comments, I got a feedback survey.
Some semi-anonymous comments.
Some semi-anonymous comments. Any questions before I stop recording? Okie dokie. Thanks, everybody.